here are supported by a high surface area, area. Okay, so the mineral oxide will yield cell to zero, right? So this dispersion process can disperse the catalytic component into a nano-sized cluster. Nano-sized cluster. Nano-sized cluster. Cluster 是小传数，跟 nanoparticle 不一样 ，nanoparticle 是金属粒子 ，cluster 是比较 general 的称呼，叫 cluster 传数。OK，nano-sized cluster，the nano-sized cluster can generate a high catalytic surface area, so which maximize their accessibility to reactants. Okay, so there is a figure showing that platinum ideally disperses high surface area of aluminum oxide shown here. This is ideal, okay? Ideal dispersion model of platinum area high surface area of aluminum oxide. So you have very dispersed. You see, this is a platinum nanoparticle, platinum nano-sized platinum. Very dispersed, and there's no aggregation accuracy. There's no aggregation between particles. This is ideal case. But in real case, 实际上可以分享给大家看一下啊，就是我是刚做的嘛，我是刚那个来看，做到这个地方啊。这个是有接近 ，this is much like approaching the ideal. So this is a platinum 3 forming this is a nanoparticle dispersed a couple. This is couple. Okay. This is a TEM image. Okay, this is TEM image. So here the top spot, the very top spot is a platinum nanoparticle. Dispersed onto a couple sphere. So this is support. So this is catalyst. Okay. This is support catalyst. So the size is around 3 to 4 nanometers. Very small nanoparticles for fuel cell application. Okay. So this is a larger image. This is a spherical larger nanoparticle dispersed onto a couple sphere. Okay. So this is a real case. So you can see there's a small aggregate right here. This is where dispersed, where dispersed. You see there's a small aggregate. You will get to a small aggregate. 能分散起来不容易，这个是用了好多方法、技术才能够把它分散走。就是有加一些 KPA， 就是外面有一些 OAS 的 KPA 嘛，就是 KPA， 它长做这个保护器，它长来做这个保护器，然后我用这个就是装在一起，就可以用在一起。这个是。Okay. So this is ideal case, very separate from the real case to CPNB in South Africa. Okay. Okay. So then in the PT side, PT are bound to operate the surface functional fluid. Functional fluid. Okay, like OH group, like OH group. Okay, to improve the dispersion, right? Then you spread. For example, this is carbon. carbon surface is very smooth, very flat, very smooth. There's no effect on the surface. So the catalyst on the surface is very easy to activate, right? Activate. But in the carbon, we have some functional group like OH group, like OH group. Okay, so the catalyst is very easy to enter， 是重在，就是癌基本上会比较容易留在附着在这个官能体上面，会增加，会改善这个分散性。这个时间过前我就知道，这会改善。Okay, so if you have some functional group like OH on the surface of the carbon, it can play an important role in dispersing the plastic particles. Where the anchor inside, the plastic is anchored on the surface of the functional group. So you will have a plastic anchor on the surface of the OH. 这样有一个帮助分散性。Okay. So commonly, the surface of the carrier has functional group like OH that provides some anchoring. Provides some anchoring of the catalytic components, maintaining them as stable as possible or stay functioning. Okay. Although supporting a catalytic component offer the benefit of maximizing the catalytic surface, it does introduce the transport issue. Where the reactants are must fused to the dispersed catalytic site in the closed network of carrier. 就说你分散了但是你的 carrier 的结构有关系或这个结构会很复杂，因为你要反应，你要东西进去，传输进去反应嘛，那你把它堵住了反应。Okay. So this supporting this carrier, the carriers is beneficial for maximizing the catalytic surface area. But there's another issue, transport issue. Okay, the carrier brings another important issue, transport. You reactor have to transport to the reactor site, and then after the reaction, you have to fuse back to the floor. Okay, the reactor must fuse to the dispersed site. Okay, so there are many designs of the catalyst. 出面有很多种设计的，可以把设计本身就有多种，有很多就这样的。比如说，也就是学生开导 X 怎么样，就可以把这个触媒把它设计成多孔，比如说有像那莲花一样、兰花一样。OK， 所以呢，这个反应可以扩散到这一孔洞里面，来去反应怎么样？可以扩散到这一孔洞反应，不会是颗球这样，它这个球上面有很多反应，它可能 OK，so this is like this catalyst or like a flower. You have a very high surface area between this plate image from that. Alright. So you have like flat catalysis one is area. Okay, so you have a very tiny particle, flat particle there. So this is the shows the plate catalysis support. This is 4. This is 3D networks. This is 3D networks 4. So you have many catalysis plates support on that board. So you form like I mentioned, it's like chocolate chips dispersed like a cookie.可以设计不同的触媒的形状，给它设计多孔的，或是把这种花状，然后表面积大一点。然后呢，你又可以把这个花呢，或把这个触媒就把它分散在一个更大的题材上面，可以让整个发现说更流通，不会做很多种设计方式。OK， 对。Okay, just called issue. So you can disperse your catalysis onto a 3D structure. Where it is good for reactant just potential. Okay, like I showed you the data, incident data. Okay. To maximize reaction rate, it is essential to ensure accessibility of all reactants to the active catalytic site. OK， 那我们来讨论更细一点的哈，更详细一点。这个是 we like to discuss more detail about what happened with the chemical what happened with the heterogeneous catalysis process. Okay. So the example is now we consider a physical and chemical state. Okay, physical and chemical state. Occurring during the heterogeneous CO oxidation in heavy phase catalytic reaction. So CO, carbon monoxide, and O2 molecules are flowing through the bed of a solid particulate catalyst. To be converted to CO2, the following physical and chemical state must occur. 好 ，CO 加入部分的 CO2 呢，要走下面这几步骤，有些是物理的，有些是化学。OK， 对，convert CO and O2 to proceed the following there are some steps after during the catalytic reactions. The first step is you have CO and O2 in an upflow. So the first step you have to diffuse through the outer surface of the catalyst, the outer the outer gas surface, gas sphere, we call gas sphere. Okay, this is the top mass transfer. 讲这样好不好 ？OK， 画个塔图给大家看一下。OK， this is catalyst。学课破坏烂的话 ，this is catalyst。So you have a pore. You have a pore. Okay, this is catalyst. You have a pore, like this one. Right? This is a spherical catalyst. You have a pore. You have a pore, very pore. Okay, you have a pore. Okay, so there are diffusion layer more small. The outer surface of catalyst have a very thin gas layer. We call diffusion layer, 扩散层，就more small diffusion layer. Okay. So the first step is your CO1 and the O2 have to diffuse through the diffusion layer. Okay. Your CO and O2 must diffuse from the flow through the diffusion layer. So this step is called mass diffusion. This is step 1. Step 1 is mass transfer. And the second step, CO and O2. If your reaction is taking place here in this side, so you have to diffuse through the pore, right? You have to diffuse through the pore. 这在反应风险教过大家孔洞扩散，对不对？孔洞大，孔洞小。孔洞小到某程度有什么扩散？撸的是diffusion，了解吗？3还没上到4有上过的。好，如果没有记的话，孔洞越小越小，小到某程度，那个叫做撸的是diffusion。撸的diffusion。OK。撸的diffusion就是97，然后去跟97乘上根号 m 乘上它的好 ，so the second is pore diffusion， 孔洞扩散 pore diffusion。And then step 3, step 4, and step 5 is your CO have to carry salt, carry the salt on the surface and the bottom, and then proceed a chemical reaction with another product, and then dissolve. Yeah. So the step 3, 4, and 5 is taking place on the surface of the canals. So the third step is chemical. Right? You still have salt on the bottom side, and then reaction. And then dissolving. Okay, so we have heavy solution on the surface and chemical reaction on the CO2, and then your CO2 have salt on the surface. And then the same process, you have to go and pour diffuse back to the floor, and then back to the floor. Okay, so this three step is taking place on the surface of the canals. Absorption, integration, and dissolving.好，有记得了，我们等一下来看文字了，来看文字的时候，你就要想象这个，反正第一个你先扩散一个，经过一个扩散层，然后再空中扩散，然后接下来吸附表面反应的波幅，然后再空中扩散出去，然后最后再扩散出一个一个边界层，扩散出去。OK， 我大概把这个流程先翻到一边。Okay. Keep this process in mind. Okay. Okay, for the first step, CO and O2 must make contact with the outer surface of the area. To do so, they must diffuse through a statement thin layer of gases or outer layer, forming around the outer surface of supporting particle. Okay, must diffuse through a statement is the teeth segment.这个是过程法，按照视力上面有一个过程叫做 statement。 diffuse A plus A B，A 在不进行的 B 中扩散，等于导致 same process。其实对 ，second 这个单词也是到先。A diffuse through a non-diffusion and the standard B, right? Diffusion model. Okay, through a standard big layer of cases of boundary layer forming around the outer surface of the So one molecular diffusion rate varies approximately with G 的6%。Approximately with temperature 2/3。And typically they have activation energy, apparent activation energy. Activation energy is around 1 to 15 kilojoules per mole. Okay, so there's an explanation here. The term apparent activation energy is used here to distinguish the physical phenomena of diffusion. 就是扩散的活化力，它不是真的反应活化力，它把它想扩散的意思，把它想的活化力。Apparent activation energy from the truly activated chemical process. Process that occur at the genetic site. 就是说，一般我们讲的活化的反应嘛，反应从低温可以到位，但是扩散也有活化，对不对？扩散有活化，外面的扩散，没有？扩散它也需要能量啊，或扩散，然后要加扩散，所以它也需要能量。所以它为了要区分这两个活化的差异，把那个 apparent activation energy is used to here to distinguish the physical phenomena of diffusion from the truly activated chemical process. Okay, so the diffusion process is a physical phenomenon. It's a physical phenomenon, and so a non-activated process. Okay. It's a sentence remind you transport phenomena, 输送现象，会让你回想到 transport phenomena, the diffusion coefficient, the diffusivity AB1, AB is proportional temperature. 在讲这个，还有回忆吗？刚上完课，上一学要修完，对 ，OK。So the diffusivity, right? Diffusion coefficient or diffusivity, AB is proportional to temperature. ，Okay. Or there's another equation shows AB proportional temperature 1.75, right? Remember that? activation energy for photon fusion is a little bit higher, right? It's around 25 to 35 joules per mole. It's a bit higher than the bulk fusion. Right? This activation energy is lower than this one. Photon fusion, right? 孔洞过程阻力更大，对不对？都会因为结构不变，会撞到墙壁，撞完之后呢，那个一些能量可能释放掉，这样子就更大。Okay, so the photon fusion has higher resistance for fusion. So it is a higher activation. Then it has a higher activation, error activation energy for photon fusion. Okay. So step 3, step 4, and step 5 is surface. Okay. So once CO and O2 arrive at the magnetic side, then heavy solution. Wow. Heavy solution of both O2 and CO occurs adjacent magnetic side. Okay. So the kinetic generally follow exponential dependence on temperature. Exponential times A over R. Minus E over R. So E3 is activation energy for heavy solution. Okay, activation energy for heavy solution. Activation energy. Activation energy for heavy solution. Activation energy. Which for a heavy solution is typically greater than 40 kilojoule per mole. This process I can remind you. Here, okay, the O and O2 have solved the surface, and your surface is able to compress, become a CO2, and then your CO2 can solve from out from the surface of the So this is step 3, step 4, step 5. Heavy solution, chemical reaction. Okay, this is the heavy solution. Okay, step 4. Okay, so the big step is CO distortion and distortion. CO distortion. CO distortion. They also follow the okay, then the next, the following two processes are simple. The dissolved CO diffuses through the porous network toward the outer surface with an apparent activation energy that is similar to step 2. Step 2 is contribution. Step 6 is also a contribution. So the final step is CO must diffuse through the stagnant layer and finally to the off gas. Okay. So the reaction rate follows T. Activation energy also similar to step 1. Okay. So the step 1 and step 7 represent the clock motion. Which is the function of specific the dynamics of the flow conditions and the geometry surface area. Okay. So the diffusivity is the function of how big, how large, or not. Molecular weight, right? Temperature, and the dynamics of the flow conditions. Well, and the cold diffusion, step 2 and step 6, okay, depends primarily on the size. Size, length, 动大。Depends primarily on the size and what and the shape. 形状，你是那种弯弯曲曲的孔，这种形状，这种叫做实验曲孔，没有？叫做 capillary diffusion， 还记得吗？如果是这样子的，就叫做 capillary diffusion。Depends primarily on the size and the shape of course pore and the diffusion reactants and step 3 to 5 are related to chemical interaction of reactants and products like the catalytic side. Okay, the shape, texture, or the size, like size. Remember, fluorescent diffusion. Fluorescent diffusion, right? Here, or if you're being reflection is much higher than pore size. Pore size very bulk diffusion, cold diffusion, heavy distortion, heavy distortion, cold diffusion. All of the seven steps can be represented step in control the overall process. Depends on the reaction condition. Okay, the rate controlling process then takes the overall rate of reaction observed experimentally. So in kinetic process, it is essential to understand what process limit overall rate of reaction. Okay, 好，诊断观念这几个步骤，每一个步骤都有可能是速率决定步骤。老师，这扩散不是很快吗？没有，某些条件下面它是速率决定步骤。因为经过到你去看说，对吧？扩散控制就是当你温度很高，或是湿感受力很大的时候，这系统在你去看过，这个扩散控制。OK， 或者什么？是传什么动力控制，铁力掌握，用一根小区用力量变成体力掌握，就看你的反应条件。OK， 好 ，sometimes the system will be diffusion control, so your reaction rate is controlled by the diffusion process. But some conditions where your system is controlled by the kinetics, so your reaction rate is controlled by kinetics, by the reaction rate of the surface tension. So the rate of each of these processes is a function of relation condition. Is function of relation condition. So the design of the data spec, the properties of the data as relation condition change. So will the rate of each of these processes. And the rate limited state, the rate limited state may change. 会变not change, may change. 这两个观念很重要。Very important concept. Which step is represented depends on the condition. So you have different reaction conditions. Okay? Very important. As reaction conditions change, so will the rate of each of these processes and the rate of unity state may change. It will be Okay, so the following is given. This is更深入的解释。Okay, so this figure is a very detailed explanation of what conditions where many control, do control, and bulk control. Okay, I will explain that to you. Okay, let us stop here and下周是碰见，see you next week. Okay.